Hey everyone, it's Mr. Wistar again, and in this lesson we're going to learn about multi-threading, which is an extremely important concept. Once you start writing programs where you need more than one thing to happen at the same time, you're going to have to use some form of multi-threading. In this video we're going to talk about two ways to do multi-threading in Java. One of them involves using the timer class, which allows you in particular to create events that will keep happening at some sort of fixed recurring rate. And the other form of multi-threading we'll talk about is using the thread class. And we'll talk about what the difference is between those two classes and when you might decide to use each one. But let's get into a little bit more detail about multi-threading and why you really need it. So essentially, when your program runs in Java, it runs in something called the program thread. And the Java program, when it's running, has control over that thread. It decides what's happening at any moment in time, and it's the only one that can decide what's happening then. If you have ever written a program with an infinite loop, you've discovered this to be painfully true, because no matter what any other part of your program wants to do, the part with the loop has to finish before the next thing that can happen. Everything in the same thread has to happen sequentially. And that's not good when you want to have more than one thing happening at the same time, because the second thing can't run until the first thing is finished running, unless you have something called multi-threading. So if that's the case, you're going to need to use one of the techniques that we're going to learn, which will allow you to create a second or multiple additional threads in your program. Remember, each thread in your program is a set of code that can run on its own and can run at the same time as the other threads in your program. They're not really running at the same time. If you want to learn more, go onto the internet and read a little bit about how multitasking works. Essentially what's happening is that your program is pausing and switching between threads so quickly that you can't even notice that one is stopping and the next one is beginning. Just as a couple of examples, and I think some of this will come up for you in your final projects, but anytime you've got, say, a game where you've got multiple things happening at the same time or multiple objects on the screen, anytime you have any sort of animation, it's really important to have multi-threading because you need one part of your program to update the data and you need another part of your program to redraw the screen. And another example here, anytime you have just something that needs to be running in the background and monitoring things, you need another thread for that. You can't run in the background unless you're running in your own thread. Okay, let's talk about the first kind of form of multi-threading that we're going to learn, which is using something called the timer class. So the timer class is good for scheduling things to happen at a certain time. It's also good if you want to schedule something that's going to keep happening over and over. So for example, if you have an object in your program that needs to move across the screen, that's a really good example of when you might want to use timer and timer task, because your object needs to update its position every couple of milliseconds in order to create the appearance that it is being animated. Now, the easiest way, I think, to implement this in your program is to use an inner class inside of the class that needs to be updated. The reason why using an inner class is helpful, remember, is that inner classes have the ability to access the variables of the outer classes that they live inside. So you can put your code to update the object in your inner class, and it can update the variables of that object. Now, we're going to be writing an inner class that extends timer task, and there's only one method that we really need to implement, which is this method public void run. That's the method that is going to be run every time you schedule an event of that timer task to run. Now, in order to actually make that task take place, you also have to use the timer class. So remember, we have two classes, timer and timer task. Timer task actually has the code which makes stuff happen, but timer is needed to actually control when the timer task runs. And there's two methods that you will need to use, and you can go online to read about the syntax and the parameters for those two methods. There's schedule, if you just want something to run once, and then there's schedule at fixed rate, which is when you want something to run repeatedly. In both cases, you can set up some sort of a delay. So if you don't want the task to run right away, you can add a delay that will make it wait a certain amount of time before it runs. If you want it to run right away, then you can just set the delay to 0. So let's see an example of that. So I've written a simple program called thread demo. First thing you notice here is that my class has its own run method. That's not the timer task run method. That's just the method which is going to make our program go. So in here we've got a class variable called mynum right here, and we're going to start off equal to 0. And then here's our timer, and it's going to schedule at a fixed rate a new object of our updater class. That's our timer task class that we'll look at in a minute. It's going to start immediately, and it's going to run every 100 milliseconds, or every tenth of a second. Now what's going to happen inside of our timer task? So here's our private class updater that extends timer task. It's very short. It has one method, public void run, and all that method does is updates the value of mynum and then prints it. Notice that we don't have a loop in here. Sometimes you might be tempted to put a loop in here, but remember, the schedule at fixed rate method up here is what's going to take care of the looping. You don't need to put a loop inside your run method. Your run method will run once and then it'll be done. So let's see what happens when that program actually runs. So we'll go ahead and run. And if we look down here, look at that. So every time the updater is scheduled to run and runs, it calls the code inside run method, which adds 1 to mynum, and then it prints out the new value of mynum. This is happening every tenth of a second. Okay, let's go back to our slides on multithreading. Now the other kind of multithreading that you may want to do is using the thread class. Now the thread class is a little bit more general. It's also tends to require a little bit more complex code on your part, but it's really essential if you have particularly for some sort of process that needs to be running continuously but not inside the main thread. So a good example for this, as I mentioned before, is if you've got a graphics program and you need to be repainting the screen. So that needs to happen repeatedly. It's not going to happen by itself. Java doesn't call repaint. And you don't want to be putting those repaint calls inside your main thread, or else you'll bring your execution to a halt. What you really want is a separate thread that can just call repaint over and over and over and over again in the background without you even needing to worry about it. So the way we're going to do that, again, we're going to have an inner class that's going to, this time it's going to extend the thread class. Now, unlike timers, where you had two classes, timer task and timer, in this case we just have one. Your inner class is going to extend thread, and then in the place where you want your thread to run, you're going to create an object of that new class, and then you're going to call its start method. When you call start on a thread, what it does is it looks inside that thread's class for a method called run. Again, it's the same name of the method. It's called run, just like in timer task. The difference here tends to be in the way that you implement it. So just to talk a little bit about that, normally what you'll see in a run method for a thread class is an infinite loop. This is one time when, as a teacher, I give you permission to use infinite loops. Because if you need something to be running continuously in the background, you're going to need to have some sort of loop which is going to run for a very long time. Your main thread can kill whatever your class is that implements thread by calling its stop method. So I'm not too worried about that infinite loop, and even if it did keep running, it's in a separate thread, so it's not going to interfere with the way that our program executes. Now, the other thing which you're probably going to need to have in your program is somewhere a call to the method sleep. If you don't tell your thread to go to sleep, even for a millisecond, what I've found is that it does tend to appear as though your program isn't, or your thread isn't running at all. And I think that's just because Java doesn't have a chance to kind of slow down and update. It's running so fast that it's not able really to kind of perceive what's changing in your program. And so what I've found to be helpful is to just put a very simple call to sleep inside my thread, and that just seems to help it kind of pay attention to what's going on. Okay, let's see another example of that. So if we look at the second version of thread demo, all the code from our first example is still here, but we've added some code. So notice here I have a class called checker, which is my thread class, and so I need to create an object of that class, and then I need to tell it to start. If we look down here at my checker class, here's my run method, here's my infinite loop, here's what's happening. So we have an if statement that says if our number is gotten to be larger than 10, then we complain and then we reset it to 0. And then we call sleep. Again, all you have to do is sleep for a millisecond and everything seems to work fine. Now, the other thing you might notice here is that we have this unfamiliar syntax, try and catch. Try and catch, I don't want to get into a lot of detail about that. What it does is it checks to see if something bizarrely terrible is going to happen in your program. Nothing like that is going to happen, but Java won't let you compile unless you possibly catch that exception. So I'm going to catch that exception here, and I'm not going to do anything with it. It's a little bit of poor programming practice, but just for the sake of this example, we're going to let that go. So it's okay. Don't report me. Let's see what happens when we run this program. Again, remember, our timer task is still running, but our thread is running continuously, and when its if statement becomes true, we should see something happen. So let's go ahead and run that. So here we go. Again, we're counting. Whoa! Okay, so notice what's happening. So now our thread class is able to realize when our class variable got too large, and then it reset it back to 0. So we actually have 3 threads in our program running now. We've got the main thread, we have our timer task thread, and then we have our checker class, which also extends thread. And each one of those is running on its own, doing what it needs to do. So again, just to review, in this lesson we've talked a little bit about the need for multi-threading if you have simultaneous actions in your program. We've talked about how to use timer and timer task if you want to schedule something to occur at a certain time. And we've also talked about using the more general thread class if you just need to have something happen, particularly something that's running continuously. All right, you're all set.